In college algebra, we moved on with graphing rational functions. On Friday, we talked about vertical asymptotes. And today, we're talking about horizontal asymptotes. So there's some pictures of what they look like. They're the dotted lines you see in the pictures. And the graph gets really close to those dotted lines, to those horizontal asymptotes. We have three scenarios that we need to account for. So these are not steps to finding the horizontal asymptote. These are scenarios. All right, so n is the largest exponent of the numerator. It's another way to say it's the degree. So for m, that is also the largest exponent, but of the denominator. So all you're doing is you're comparing n to m, and if n is smaller, then it's a quick answer. You know y equals 0 is the horizontal. If they are the same, they equal each other, then you have to figure out this fraction. A sub n is the lead coefficient of the numerator, and B sub m is the lead coefficient of the denominator. So if the two exponents, if the degrees are the same, you put those two lead coefficients over each other and you reduce. If n is larger, that's scenario 3, you just say there's no horizontal asymptote. So on 4a, n is 1 because there's an imaginary 1 right there. M is 2. So n is less than m, that is scenario number 1. That means y equals 0 is the horizontal asymptote. For question B, let me change colors. N is 2 because of that 2 right there. M is also 2 because of that 2. So n is the same as m. That's scenario number 2. That's where you find a sub n and b sub m. So those are the lead coefficients. A sub n is the 4. Another way to say lead coefficient is the front number. And b sub m is 2. That 2 right there. So you put them into a fraction, 4 over 2, and that equals 2. So y equals 2 is the horizontal asymptote. All right, one more. For question C, n is 3, m is 2, n is larger than m, no horizontal asymptote. All right, let's give a whole problem a try. We're going to graph an entire rational function. So we're going to use the 5 steps that you see at the top. In the videos, I did not go over steps 1 and 2, but that's because they're pretty self-explanatory. So for step number 1, let's go very slow and organize this. I'm going to plug in 0. And when I plug in 0, that's my y-intercept. So I plug in 0, and I end up with 0 over -1, which is just 0, and that is my y-intercept. So we're going to make a dot on the 0. For the x-intercept, where the numerator equals 0. So that means I am going to solve for x after I set it equal to 0. So step number 2, I take the numerator, 2x, set it equal to 0, divide both sides by 2, and 0 divided by 2 is 0. And I already have a dot there. I don't have to make a new dot. Step 3, that's what we did on Friday, vertical asymptotes. You set the denominator equal to 0. Solve for x. Many times this means factoring. Sometimes it can't be factored, so you just solve it. Could mean quadratic formula. However you solve it, that is what the vertical asymptote is. So our denominator is x minus 1. Solve for x, and that is our vertical asymptote. So I go to 1 on the x-axis, and I make a dashed line. All right. Calculator doesn't help with that step. Step number 4, I want to find horizontal asymptotes. N is 1, because there's a 1 right there. Should I draw an arrow? That 1 right there. M is 1, because there's a 1 right there. And now that is N equals M. That's scenario 2. I need the lead coefficients. A sub n is 2. B sub m is 1. Y equals 2 over 1 equals 2. So you go to the y-axis at 2 and you draw a dashed line sideways. That is our horizontal asymptote. Step 5, I'm out of room. I'm going to do it top right. So you want to make a table, and notice what I typed there. You need to plot at least 1 point on either side of the x-intercept and vertical asymptote. So let me change colors and note what we want to plug in. So I'm looking at the vertical asymptote. I'm going to plug in a -2, a -1, a 2, and a 3. That way I can see some kind of pattern left of that line and right of that line. Now those are not actual coordinates. I'm just trying to get you to see where I'm looking right now. So I'm going to plug in -2, -1, 2, and 3, and that's going to guide our graph. So we go to the calculator. Let's go to a graph, press Control Divide. 2x divided by x minus 1. Now notice it doesn't show asymptotes, but I can do Control T, and find some of those coordinates. So at -2, it's 1.333, and at -1, it's 1. At 2, it is 4, and at 3, it's 3. So plot those points. And these make parabola-looking graphs. And that's it. All right, you have a good one. See you later.